Bismillahirrahmanirrahim. Assalamualaikum. Welcome to my YouTube channel. Now, welcome to my YouTube channel. Now, now in this later we have started the communication system lecture series, and the first lecture, which is named is signal analysis. So this is the outlines of my lectures of the communication system first lecture. Now, first of all, introduction to subsignal analysis. Sorry. The first point is the objective of this chapter is to provide this data with the necessary mathematical basis for understanding communication systems in conjunction. Conjunction meanings are with probability theory and stochastic process. Now, I will tell you what is the conjunction with probability with the probability theory. This basically is the conjunction with probability means the intersection of the events. I will detail discuss about in the next video there in detail. And now I will also tell what is this stochastic process. Oh, it's called the mathematically model that discusses a collection of length-term variables in text by time or space. Now, this later will become familiar with concepts and equations involving in Fourier series, which are significant statistical elements for the theory of connection. You are relatively familiar with Fourier series in signal system, digital signal process, digital image process, in linear algebra, calculus, and many more sub-courses of the engineering. I will detail now. In the next slides, I will explain detail. Now, furthermore, both the theory and properties of Fourier transform represent which constitute powerful tools for spectral analysis. Now, I will tell you about what is the spectral analysis. Spectral. It's a method used to decompose a stationary stochastic process into constitute clinical operative other components. Now, Fourier analysis. The basic Fourier theory established fundamental conditions for the representation of an operative function for not interval. So some options it only some of these sine waves for the explains about this. Now, in fact, this is just an instance of the more general. Now, Fourier representation signals in which a periodic signal are explained the signal and system detail. It's all chapter 4 to 5 chapters, I think, is about the periodic signals. By a complete set of S of orthogonal function, it's understood that except for those orthogonal function nothingness. So it is the combination of the maths and the engineering computer. In this course, you will learn about property, integration, and Fourier series, Fourier transform, and everything in which in this course. And this numericals also in detail. A technical function is not ranked as to vacancy. It is assumed in the sequel that the periodic synchronous. It is same thing that the periodic synchronous must be satisfied of the orthogonal functions in satisfy the conditions. That is, f function t is a bounded function which in any one period there's most finite number of local maxima and minima in calculus. You have already learned local maxima and local minimum in the derivatives chapter. You have also done. Now, the representation of sequence for orthogonal functions as series very often in which determinations the number of component terms in corresponding is increased. This is the first figure I've shown. Look, this is the sound of which is like, and the previous slide I've described. Some of sinusoidal. Now, the first point is the fact that a periodic signal can in general be expanded as sum of mutual orthogonal function demands for close to look at the concepts periodicity and orthogonal. Is the basic I will tell you the next forwards. Sorry. Now, periodically relates to the repetitive character of the function. A function f of t is defined by the function period t. Different only if t is the smallest positive number of each periodic signal. This signal, I will tell you, this is the periodic signal. Periodic signal. In other words, function f of this periodic is submit constant sin t plus capital T. Now let's check. Continuous time ripple plus time period of periodic signal. It follows the definition of periodic signal that if t represents the period of f, then f of t f the periodic signal. Now f function t plus n t. For n is equal to 1 to the up to so on. We'll repeat this value and integral level of t. It is Ocean curves and trackers of the scientists that they discovered this equation. Now, figure represents a periodic signal xt with period and t, 2d, and amplitude t. This figure is already mentioned here this figure is telling about linear. If f of t and g are two periodic functions with the same period t, the sum and then the sum f of t plus g can also be a periodic function with a period of t. The very interesting point is here. Now, We prove this results by making h d by the f of d plus g of d and noticing that h d plus d यानी h function periodic signal जैसे तो f d plus d periodic signal plus g periodic signal so f of d plus g of d इसके तो h we shall not investigate the concern orthogonal narrative. Orthogonality was a tool for introducing four concepts of surface that is minimum set of function can be used to generate other is talking with minimum maxima. However, orthogonal by itself does not guarantee that the complete vector space is a non-scalent vector concept is talking about in this slide. Two real function u of t is equal to 4 I scale and v of t is equal to t. Two factors means I have already studied in maths FSC. Defined in the intervals alpha is less than equal to t is less than equal to b. Alpha b. Then the kernel if the inner product is null, that is u of t is equal comma v of t is equal to integral upper limit lower limit upper limit is beta lower limit is alpha. Now this is function integral we have taken. That if t is equal to 0, this is first equation. Now the set of functions f and t as listed in figure 1.2 that are in the next slide can be used for the Lieber signals in the time domain. This set of functions constitutes an orthogonal set in the term minus t time time. This is the figure we just already explained the previous slide, right?
6,000 6,000
This is the this is this is the equation we have to the
कर रही है
no. The next slide, the trigonometric Fourier series. The trigonometric Fourier transform is the most important topic of this lecture. In the first chapter, I will enter after I will show you in which book I will show in the lecture. Though the trigonometric Fourier series represents for second f of t can be written as f of t a naught in sigma infinity n is equal to 1 and cos and omega t plus p and sin and omega t. I will detail explain when the point numericals in which the term is you the average value of the function of the integer vector, not the signal continuous at DC. DC means direct current value at the term an and pn. A denominator in the Fourier series coefficient. The ACU, an and pn, these are the coefficients of the Fourier series, in which n is a positive.
फिर इधर क्यों उधर देखूं नहीं रही मुझे
N is positive. Don't use the negative integer. It will be show show error because it is scientifically proved by the researchers, by the engineers. Now, the equality sign shows in equation 1.2. This equation I'm still talking about. Values of the element f is periodic. In Fourier series formula transform, the signals is the periodic. In this case. However, the Fourier series representation is useful to any type of signal. As long as the signal representation is taken only in the zero is equal to capital theta. Let's talk about the sum of sinusoidal waves. Now, all such intervals, the Fourier series representation will always be periodic. Now, the interval Fourier series, this is the interval, will always be periodic. With unperiodic, it will do not justify the Fourier series. They cannot be still researchers scientists to discover this research work in 1990. In fact, it is the researchers and engineers I'm talking about. Desired and concerned functions are examples of orthogonal functions because they satisfy the following equations for integral values of n and m, denominated orthogonal relations. In the previous slide, there was a and b coefficients. Now in these slides, they take as n and m. Integral t0 cos n omega t sin m omega t derivative t. The t is property time derivative is equal to 0. For all integrals n is equal to m. This equation 1 by t. Now equation for 0 is equal 0 if n is not equal to m. After if n is equal to m. This is the condition. Now if 0 is equal to 0 if n is equal to m, sorry, in this equation is the cos n omega t cos m omega t derivative t in this condition. Now if the again this both n m formula will be signed. Now in which omega naught is equal to 2 pi t, capital T. As a consequence of the orthogonal conditions expression for the coefficients a and p of the Fourier trigonometric series can be computed. Last two slides, they are talking about the trigonometric functions of the integral. Now, by integration, both sides in expansion equation 1.2 this equation. Integral t of 0 f of t times derivative t so the integral t 0 a now derivative time plus sigma infinity n 0 time. Now, this sigma integral of m cos omega cos n omega t derivative t plus sigma infinity integral t 0 p and sin n omega t and series integral t 0 n cos n omega t derivative t is equal to integral t 0 p and sin n omega t is equal to 0. Is talking about this equation. This equation. Okay? It follows the a naught is equal to 1 of the integral t 0 f of t derivative. If in this condition is not then we have to do is the simplification of f of t. F of t is I think 1. So the other function will be so now I'll explain I will later. Now by multiplying both sides in expression by cos m omega t and integrating the integral 0 to for less than integral t c f t cos m omega t derivative t is equal to f t 0 a not cos m omega t derivative plus
नहीं कुछ नहीं हमको अपना करो
plus summation theta n to integral t sim n
तो देख ले पेरेंट्स
and cos n omega t cos m omega t plus sigma omega n so negative 0 p n cos m omega t sin n omega t t. After this calculate this thing and the answer will become of this integral. Now, which of the simplification process A and 2 over time t integral t0 f of t cos n omega t that of t. For n is equal to 1 to t and so on. In a similar manner, Pn is found by multiplying both sides in expression 1 part which is expressed by side n omega t and integrated in the double soon time period of periodic signal. This Pn is equal to 2 time period of periodic signal take time period periodic signal 0 f of t sin n omega t then finally set 1 to t. Now, even function and odd functions comes. A function is called an odd function if it is anti-symmetric with respect to ordinary axis. That is, if f minus t, so f minus t is reversed in h minus t and t I assume to belong to the function domain. Examples of odd functions are provided by the function t sine t and t modulus 2 and plus 1. Similar functions called an even function if it is symmetric. So this one is the odd function, the next one is the even function. This even function is symmetric and odd functions and if the question comes from of the numericals, in most of the problems come into the extents. Odd function is antisymmetric and the odd function is antisymmetric and even function is called symmetric. So don't be confused. Examples of even function are the function 1 t squared cos t modulus t expansion t modulus t and t 2n. Now, some elementary properties. The sum, difference, and the product quotient of two functions are even function. Are the antisymmetric. The sum difference of two odd functions and odd function is called the symmetric function. The product of two odd functions and even function. Very interesting point is this C point.
ये 800 भी लगी
No, the sum difference of an even function and an odd function is not an even nor an odd function. So listen complete. The product quotient between an even function and odd functions and odd function. Two other component properties are the following. If f is an even product function of a period signal, then then the time period of periodic signal and a half minus time period of a Sigma f t derivative is equal to 2f equal half time period of product equals f t derivative t. Now, if f t is an odd periodic function for p and t, then properties f and g allows for considerable simplification and computing coefficients of trigonometric forces. Integral half period time period of periodic singular f of t derivative is equal to 0. Simple. Now, if f of t is an even function, then p is equal to 0. E is equal to periodic signal f of t equals n omega t, that is for n1 to t and so on. Positive integer, not negative integer. If f of t is an odd function, then n is equal to n. Pn is equal to time periodic signal f of t sin n omega t dt for n is equal to 1 to t. Wait a second. Oh, sorry for this disturbance. No, come to the example. Compute the coefficients of the trigonometric Fourier series for the wave from f of t
ये सही सस्ते सस्ते लेकिन उसमें ये पसंद है। हाँ, उसको लगी। तो ठीक है। आजकल तो लेता है।
f of t is equal to bracket u plus constant time plus time shift minus u plus bracket constant variable minus time shift, which represents with the p in which u of the dynasty functions and 2 time shift is less than equal to t chaotic secant. Now, solution. Since the given signal is symmetric means odd one function. Symmetric is the even function. Function to access follows that f of t is equal to f minus t and the function is zero. Table for p and is equal to c and all that is therefore going to is null and for n is equal to 1, 2, and so on. The expression for computing the average value is given by n is the half 1 by periodic integral time for periodic in half minus half periodic in f of t so the delta t. Now one of our time period of periodic signal in the equal time shift once time shift a delta t is equal to a time shift of a periodic signal. Now the previous equation, the maximum value of the relationship is half periodic signal a for n is equal to conjugate a and 2 of periodic signal integral t periodic signal CF of t cos n omega t delta t is equal to periodic signal. The variable time shift minus time shift cos n omega t and for a over periodic integral time shift since cos n omega delta t for a tan n omega t sin n omega t limit time shift equal for a time delay time shift sin n omega time shift n omega time shift. The signal f of t is then represented by the following trigonometric Fourier series. F of t 2a time shift over periodic signal for a time shift for periodic signal summation sigma n is equal to 1 sin n omega time shift n omega time shift cos n omega t. Now the compact Fourier series. There is also possible to represent Fourier series in the form known as the compact Fourier series as follows. F of t c naught t plus summation sigma n squared c n cos n omega t plus sigma n. Now, by expression cn cos n omega t plus theta as cn cos n omega t cos theta minus cn cos n omega t sin omega sin theta and comparing these results from the equation 1.2 which is equal. This is a question. Trigonometric Fourier series. Fourier series. For that, Jesus also computes C in a situation of A and P. For that purpose, it is sufficient to scale A and P and the resource scale plus P and scale to C and scale cos scale theta and for C and scale sin scale theta. So the C and scale, yeah. Now, from equation 1.15 the modulus of C and calculator. This equation. If you manipulate the sequence and series of chapter in first year math, this equation is almost similar. The materials of same combinator Cn is equal to An scale plus Bn scale. And the determine theta is sufficient to divide by B and by M. This is called the tan theta sin theta cos B and An is called the tan theta, which is mentioned here. which when solved by for theta and lux, theta is equal to minus arctan. Arctan is the inverse of the tan theta. Now the exponential Fourier series. Since the set of exponential functions e t and omega t is equal to n is equal to 0 plus minus 1 plus plus 2. In this exponential is plus positive negative integer. It's now in this condition it is positive and negative. Our previous topics are thus only positive integers. It's a complete set of an odd connection and anti of magnitude periodic time of periodics in which time t is equal to 2 pi omega divided by omega naught. Then it is possible to represent a function f of the linear combination of exponential and interval time of periodic string. F of g is the summation interval minus interval f and exponential g and omega t. In which f is equal to 1, time of periodic is equal to half the time of periodic second minus half of periodic second. F of t is equal to the e minus g and omega t derivative t. Equation 1.9 represents the exponential Fourier series expression, and equation 1.2 is the expression to compute the associated series coefficients. The exponential Fourier series are known as the complex Fourier series. It is limited to show that equation 1.19 is just another way of expressing the Fourier series as given in equation 1.2. Equation 1.2 is repeating. Replacing cos n omega t plus j sin n sin omega. No, cos is the pathetic real value and j sin is for the imaginary value. Complex numbers, you can say. Is Euler's identity. In previous equation 1.9 is follows the f of t is equal to f of naught plus summation minus 1 n is equal to minus infinity. F n cos n omega t plus j sin n omega t plus summation infinity n is equal to f of n cos n omega t plus j sin n omega t. Now f of t is equal to f of n and n is equal to f of n cos n omega t plus j sin n omega t f plus f minus n cos n omega t plus j sin. In this lecture, I found the explanation not in detail. Grouping the coefficients of the sine and cosine terms follows that f of t is equal to f of naught plus summation infinity n minus n is equal to f of n plus f minus cos n omega t plus j f n minus f n sin n omega. To compare the above expression with the equation 1.2, it follows that a0 is equal to f0, an is equal to f n plus f minus n, and pn is equal to j f n minus f minus n. And that f is equal to a0 f n an plus minus jpn 2. Now these equations here studied about sequence and series. This is your familiar with the series and sequence chapter. And the f minus n is the an plus gpn 2. I think this arithmetic series, geometric series, or harmonic series, or sequence are not the exact this equation. If you know, please tell me in the comment section. In case the function of this even that is if p is zero, then a naught f naught f n is equal to a n 2 and f minus n a n 2. Now the next example 2. Compute the exponential Fourier series for the gain of impulse. This impulse of time of periodic signal t is equal to summation infinity L is equal to minus infinity impulse t means continuous time minus n time period of periodic signal. That is slash complex coefficients occur in reference to one time period, half time period minus half time period, impulse time period, continuous time impact, E minus n omega t, n omega t that is equal to 1 over time period. Now, since integral infinity minus impulse t minus t now. Is equal to ft impulse filtering. Impulse theory can be written as ft is equal to one time period in summation integral n is essentially is gn omega t. Solution solution to complex coefficients are given by brackets in order to obtain an inverse term. It is sufficient to pass a parentage. Parentage just means 1 0. After rectifying with the party etc and EC means electrical circuit analysis. And the Fourier scientists now particularly focus on the Fourier series. Fourier series and Fourier transform. The Fourier series expression protection is equivalent to the composition of frequency components in general periodic function with P as of frequency components 0 plus 1 omega t, omega 0 plus minus 2 omega and so on. Which omegas not 2 by a time period. Fundamental efficiency multi-cell called harmonics. Another steady spectrum exists only for discrete values of omega, and that the spectral components are spaced by at least m omega. No, 40 times 4. 46 and 40 times are the very close topics, very closely relations closely related. It was shown earlier that operative functions can be used in terms of exponential trigonometric forces in a finite term. And force is finite interval and Fourier tensors infinite interval. Okay, so don't be confused. If such a function is product, this percentage can be extended for the entire interval minus finite to infinity. It is interesting also to spectral people the function general periodic or not in the entire interval minus infinity to infinity. Another to the function of this derivative interval minus time period of and time period of obtain graph of the t. It is possible to represent this function as a sum of exponential in the entire interval minus the interval in plus interval by making time period approach infinity. In other words, limit t is equal to f of t, f time period t, f of t. Now I will come to about the limit. You can use L operator rule. The rule. The f time period from t, 6 cancelled by the exponential for is f of t summations infinity n so minus f u g n omega t which omega t2 by time period. Mhm. F1 is a spectacular amplitude side of the component frequency and omega. As t increases the amplitude, the managed for the spectrum is not altered. And for its use, it will alter. This increase in t forces omega t to diminish and the spectrum to bigger denser. Until there's t is infinity omega because infinity is infinity smells small became represented by dw, which derivative of w. And then there are no infinitely many comments and the spectrum is no longer to the discrete one become continuous spectrum in the limit. For convenience, write Tfn instead of W, that is the product. Tfn becomes a function of the W is n, omega naught is error, indicates W, replacing the FWD for Fn. So one obtains F of time period is equal to 1 time period summation infinity replacing omega for 2 by 1 by the full derivative of the 1 2 by summation infinity is equal to n minus f omega e g omega t omega no. The limit is t changes infinity minus f divided 2 by the infinity I say into the f w e g omega of complex exponential. Just analyze the inverse Fourier transform. So, similarly, from equation 1 point inverse t just infinity 1 obtains f omega integral infinity 1 to the f of the complex exponential delta t. It also known as direct Fourier transform. Some understand identity as f of the Fourier transform is f of t for you transform PF omega into equals summation of Fourier transform present. Now, if f of t is equal to complex exponential, my first form equation 1.5 f omega infinity integral infinity infinity e minus a modulus d e minus g omega d delta d. Now, we have to take both the integrals now is equal to 1 a minus gw plus 1 a plus gw f omega is 2a s squared plus w squared. Now, one of two will later multiply by a minus jw by 1 and d a plus jw. Now I will tell you in the next video. Now, gate function. We are in the important topic. The gate functions are defined by the expression p the average signal power of time period t u continuous time plus time period minus u continuous time of a p minus half periodic signal or p, in which u denotes the unit step function defined as simple and represented in figure 1.3. The gate function is listed in 1.4 figure. The Fourier transform of the gate function can be calculated. Now figure on this the figure of unit step function, and this is the gate function figure. And the previous slide is mentioned. This is unit step function, and this is gate function. Gate function f omega integral time periodic signal minus periodic signal of A complex exponential complex that A J omega E J omega per x equals E J minus J omega of per x, which can be as f omega A d sine omega cut omega per x equals omega of per x, and finally as f omega E t is omega half. This is not called the entity, it's called okay. In which s x sine x of x is the sampling function.
आप देख लो कि अगर वो मासी नहीं है तो ना रखो पूरा वो था कोई बंदा वो उठा के नहीं के लिए तो पूरा ग्रुप वो शायद सभी की लगा ली
ये एलिसन क्या है?
These functions converges toward Sx close to 0. This sampling function, the magnitude of which is significant by is of great elements in the communication to. This sampling function is the following relationship. Integral in terms of infinity k by s k d these are done. The other is equal to 1. Asking the sustainability of this sampling function increase this specific zero cosmic tension most of the circular energy constants the direction for k plus simple function converges to an impulse function that is impulse function set the limit k plus infinity k by s k t. And this one, the limit is to do that the integral infinity infinity the impulse function the lattice versus the function the consider distance here. Linearity follows the impulse function reduced for t is reduced. Therefore, integral theta minus theta f t is s t derivative t phi s reduced. F is reduced is reduced as the impulse function t is reduced. In general, this possible write a 1.4 equation as integral infinity from f of t plus t is minus t naught instead f of t. No. This one relationship mentioned earlier in 1.2 shows known as the filter of the impulse functions. This is the figure magnitude of Fourier transform the gauge function. This is the figure at this point I find a team method. Mixture of Fourier transform the gauge function. The impulse function or Dirichlet's delta function. By making f of the impulse function from equation 1.35 follows that f omega integral function the impulse function e minus j omega d del. Using the impulse field in part, it follows that f omega should default impulse functions contains a continuum of equal amplitude spectral components. Alternative for making f omega is the equation 1. A simplified impulse function can be written as 1 by integral finity cos omega the not a constant function. If f this constant function, then its Fourier transform principle not exist this function the sum as the absolute unity creative of criterion. Generally for America, the Fourier transform of f is expected to it is if omega is less than or equal to integral infinity minus the integral f of the complex explanation.
उसी के आगे भी छोड़ के आए।
Less than, sorry. Since C j minus j omega is smaller than f integral minus integral f of the that is less than less than infinity. Well, that is just the sufficiency condition, not the necessary condition of the existence of the Fourier transform. Since the exist function that alternate satisfy condition of absolute integrating the Fourier transform. This is a important observation since this approach is often used in the computation Fourier transform and the functions. Returning to the constant function, it can be approximated for the current function which amplitude and with time from the function. Watch by large values. F is limit the time delay minus in to plus infinity a time delay as a omega half time delay 2 by a limit time delay infinity time delay 2 by s omega half time delay. F a 2 by a impulse function. This is a not only a very interesting one, but also some intuitive since a constant function directly represents a DC direct current level. And the S was to be expected contains no spectral comet except for the one at omega 0. Since both the sign and the constant functions appear the function that do not satisfy the condition for absolute integrable the respect the Fourier transform exists in the limit when time delay goes infinity. Assuming the function to exist only in the interval minus time delay to positive time delay and to be zero inside this interval, consider the limit to the expression when time delay goes to infinity. Also, omega this is the limit time delay infinity the integral of time delay sine omega the complex exponential that is the limit delay infinity in time to half time delay. Now we get to the main equation. If you set the limit time delay infinity is equal j the half time delay SL omega plus omega naught 2 minus j the half time delay SL time omega plus omega naught 2. This function we have to write the multiply time delay. Is formula. Therefore, f sine omega t is j by sine impulse of function omega cosine impulse omega cosine applying similar listening force that cos omega t is equal to pi omega impulse omega is omega naught plus impulse plus omega plus omega in which omega 0 is equal to pi time period. Figures 1.6, 1.7 of the this slide. Six function of current table. Yes. No, yo sé que lo soy identity e j omega not is the cos omega not j d plus j sin omega d first that substituting location 1.53 times of the sin anti-construction by f e j omega d to 2 by s impulse omega and omega no. This is the function, the compound sine function, frequency times magnitude Fourier times of the sine function. We consider next the exponential Fourier series as an of a periodic function f time period of period yet of periodic signal. F of d is the summation sigma n is the sigma and e g n omega d. Applying the Fourier transform to both sides in 1.55 it was that f of d is the f summation of sigma n to the n sigma f and e g n omega d to the f sigma n to the n f of n f e g n omega d. Now applying the rational by sinus of rational by force of omega function omega 2 by summation of nu sigma minus n f n impulse function omega
Because it's applying the following.
No, properties of the Fourier transform linearity. Linearity is an important property when studying a communication system. A system is defined to be linear system if it satisfies the properties of homogeneity and additivity. Homogeneity if the application of the singleness of the system input produced by the system over time the application of the input xt, which alpha is a constant produce alpha y at the output. Additive if the application of the signal x1 d and x2 d at the system input produced respectively one d and y2 d at the system output and the application of the input x1 plus x2 d produce y1 d plus 2y d at the output. Now, by applying the test for homogeneity and additivity, this image to check that the process that generates the signal s of the a cos omega c d plus m d plus the final false signal m d is non-linear.
The figure all conventional.
By applying the same test to this signal r d so the m d cos omega c d plus theta, it is limited to show that this is generating all this in the Fourier The Fourier transforms a linear operator that is if a function can be written as linear combination of other well-behaved functions. The corresponding Fourier transform is given by linear combination. The corresponding Fourier transform will be given by linear combination of the corresponding Fourier transform. Injunction of the linear combination. If FD implies F omega and GT implies G depth, then follows that alpha F of T plus beta G of T implies alpha F W plus beta G W. Full flat edge of T sect alpha F T plus beta G T implies then it follows that H W is Smith's convolution. And they can find the minus in the H D E minus j omega t delta. So alpha integral to infinity minus infinity f of the e minus j omega t del plus beta integral beta of integral minus integral j t e minus j omega del. Now j omega is equal to alpha f delta plus beta j omega. F A D is equal to integral minus integral A minus j omega delta d. Initially, let us consider A greater than 0 in equation 1.6. By letting it initially let us consider A is greater than 0. Which means by letting U is equal to d, the first delta d is 1 the other way du. Placing it for 80 in equation 6.1 it follows that f integral infinity infinity f e minus j w a u du. Is similar to f it is at 1 by f w a. Consider that the equation which is less than 0 by a similar position. It f it is equal to 1 minus a f omega a. Equation with 6 times 1.6 t can be combined and written as f of t is equal modulus f omega. This is response to the fact that if a sequence converges in a time by factor a, then its frequency spectrum will explain the frequency domain by the time factor. Now, Fourier transform symmetry. This is an interesting property which can be fully observed in a function. The symmetry states that f of t implies f omega then follows that f of t implies 2 by f minus omega. Proof by definition. F of t is equal to 1 2 pi plus infinity times infinity integral f of omega e j omega d which after multiplication process by 2 pi becomes 2 pi f of t and f plus integral minus integral of process by 2 pi becomes 2 pi f t is equal to f integral minus integral f omega is equal to e j omega to w. By letting u is equal to minus t for say 2 pi f minus u is equal to integral plus infinity minus integral f def e minus j delta d. And now making by d is equal to omega no one of this 2 pi f minus u f integral plus integral minus integral f of d e g du delta pi finally by adding u so that w follows the 2 pi f minus w integral plus infinity minus integral f of d is equal to minus j w omega d delta d.
Yeah. चलो वो चलो नहीं
About the Fourier transform of a constant function is the by the use of sympathy property. Since an impulse function implies a pulse that implies 2 by a pulse function minus a 2 by a impulse function. Given that f of t impulse f omega first plus that f t minus t naught plus f w e minus j omega divided g over d. So that t minus in this case it follows that g omega of g omega d integral infinity f d d naught d is equal to minus j omega by omega d time to the so that d minus d naught follows that j omega is equal to f integral j omega f of d e j omega d d naught plus dw f omega minus omega f naught e minus j omega d g omega d delta time delay. Finally, G omega E J omega df omega. This also shows that when our function is shifted in time, its frequency time and amplitude spectrum themselves another. Gravity corresponding first spectrum experience salutation proportional to omega days snow. Given that f of the inverse f omega equals that f the complex exponential first f omega is omega not f of the e j omega df integral omega infinity f of the e j omega d minus j omega d derivative d is equal to f omega minus infinity f of the e minus j omega omega now d derivative d. Now, some values of Fourier transform definition in the time domain. Time domain. Given that f of t implies f omega e time follows that the df of the derivative time derivative f over d implies g omega f omega proof. Let us consider expression for the inverse Fourier transform. F of t half 2 pi integral information integral f omega e g omega d derivative t. Derivative omega d. The efficient times it follows that the time df of the round 2 pi d dd. The integral difference infinity f omega e g omega d the second round 2 pi f integral minus integral d f w e g omega na d second round 2 pi f got infinity into j w f omega e g omega d. And then dft d j w f w. In general, it follows that the NF of the d implies g w n f. Now, converting the Fourier transform the single of the set the impulse function minus a e minus a du is immediate to show that applying the problem of definition time. This equals the time derivative of the single gt is the e minus a du. Now, integration the time domain. Let f of t be a signal with zero eventually. That is that f in integral infinity f of t d is equal to 0. By differentiating integral d minus infinity f time to let derivative time being force that d is whatever d. Since gd implies g omega, then f of t implies g omega and g omega is the f omega g omega. This manifests that for single with zero average value, f t implies f omega integral t minus integral f times the time implies f omega g omega. Generalizing for the in which shape of the s non-zero average value follows that the integral t minus integral f times the derivative from the plus f omega g omega plus y is then d omega f0. Now the convolutional theorem. The convolution theorem is the most important topic of the Fourier series for items of the signals and system the digital signals digital image process. The convolution theorem is powerful to for analyzing the frequency contents of a signal like representation of many levels. Now, sense of the use of the convolution theory of fundamental importance in communication theory. This systemic the image will be the subject of the next section. uh, section. The conversion between two time functions of t and g of t is defined by the following integral. Integral from integral f time delay g t minus time delay derivative time delay. Now, which is often known as f of t we multi s sec gt let ht is f of t gt let ht plus h omega. This is the convolutional theorem equation. Now the convolution problems will become in the exams. I will tell you in the next video. If we set h omega is set to integral infinity minus an h d is e minus j omega t that is called the double integration. So f time delay g t is minus time delay e g omega delta. Now first we have to do f of t, and after that g of the two integrations we have to do in this. Now, now, h omega is equal to integral infinity. I say f time delay infinity. Integral infinity minus g t integral E minus q omega naught derivative t derivative times the h w integral infinity minus unity f time delay g omega e minus j omega time delay. And finally h omega is f omega g omega henceforth. The conversion of two time functions regarding the frequency time to the power of their respective Fourier transform. Now in h omega 1 over 2 pi plus multiply g omega. In other words, the product of two time functions of Fourier transform given by the convolution of the respective Fourier transform. The convolutional operation is often used when computing response of a linear circuit given its impulse response and input signal. Now, this is the example there. The second figure 1 is the impulse response h over t given by h over t 1 over s e minus t are used. This example you are familiar in the ECA subject. The solution. The application of the unit impulse x over t is impulse pushes the input of this circuit. So causes an input of t h over t. And if we consider that by the convention of the input that right, the pH, the px, and so the h, that is the Fourier transform of the inverse response of a linear system is the system transfer using functions. Using the frequency condition can be shown that cos omega c du t impulse by the impulse from omega plus omega c plus omega minus c plus j omega omega square omega c square omega square. Now it is sampling to you. A band limit signal f of time having no frequency components above WM 2 by FM can be reconstructed from its samples. Collected with uniform time intervals, sampling frequency is 1 hour time sampling time interval is at a 1 hour frequency sample. But later fs in which is a frequency signal. By apparently immersing f of t, plus of n is understood that this is a frequency diagram of which is f omega, which is that is f consists for impulse omega is greater than omega m. Nyquist conclude that all the information about f of t is still significant is contained in the samples of this signal collected at the regular time interval time sampling frequency. This is the function of the frequency 1.9 which I will already discuss. In this way, the signal can be completely leaked from this sample for binary signal that is such that omega t such that omega f omega 6 for module omega is greater than omega and by showing in frequent mobile force that f of t greater than a t by t is the f of t if it's greater than omega. Because in the frequency domain, this corresponds to the product of f developed function of it greater than 2 omega and consider the signal f of as the f of the impulse function t in which impulse function time the periodic signal is equal to impulse is equal to summation sigma n is equal to infinity impulse function t is equal to n mod capital T. And the fighters of the disease samples of one happens. Delta T omega is equal to omega naught definition. Infinite L is minus impulse omega minus n omega naught. Kana. 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 This is the function 1.10. Copy. This signal impulse time period that is a figure 1.9 is 3 times this figure. So this is the figure 11 plus 10 is for sampling and this is for e transform the impulse 10. The signal effect the frequencies in parallel represents the sample different time intervals sampling time. Seconds from this frequency condition it follows that the Fourier transform of the product of two functions time domains is the condition of the respective Fouriers. It now follows that frequencies sample t in plus 1 2 by f omega over delta t omega. And thus frequency sample plus 1 over t summation infinity n is equal to f is equal to omega n omega naught. Not Figure 1 where the shows the sample signal 367 sequence. It can be observed from figure 1.4 that the simple frequency omega s is than 2 omega n. Can there be an overlap? There will be another spectral complex. This is spectrum sample frequency. This will cause a lot. This will cause a loss of informal because the original signal can no longer be fully cut from its samples. As omega samples becomes smaller than 2 omega, the sample frequency 2 omega n can delay diminish, thus causing a partially loss of information. Therefore, the minimum sample frequency that allows perfect as WS becomes smaller than 2W, the sampling rate damage exponential loss in function. Therefore, the minimum sampling frequency that allows perfect because this sequence omega signal to omega and thus also a Nyquist sampling rate. In order to recover the original spectrum of omega, it is enough to pass the sampled signal to low pass filter which cut off frequency W. For application in telephony, the sample since FS data samples per second or 8K samples per second. Then the speech sequence converts as well as discussed data for 256 days, and each line corresponds to an 8-bit code 256. Then coding the sequence transmit a rate of 8,000 samples per second, made per sample 64 kilobits. Under the subbandwidth of approximately 60 Hz, if the sampling frequency W is slower than 2 pi, they will be spectral relevant consequence information. Therefore, the sampling frequency for baseband signal duplicate losses W is 2 pi be known as the Nyquist sampling frequency. As just mentioned, if the sampling frequency is lower than the Nyquist frequency, the signal will not be completely covered. This seems to be spectral superposition, leading to this version to highest frequency. This phenomenon is known as aliasing on the other hand, increasing the sampling frequency for value higher than the Nyquist frequency as to spectral separation at the minimum necessity to recover this signal. Now, Parseval theory of Fourier signal. Parseval is this scientist which discovered the engineering energy signal and power signal. Fourier signal of energy often called simple real energy. The energy has a relativity of this given from E theta integral infinity and F square d to the integral can be calculated by E theta 1 2 by integral in infinity F omega square F omega. It follows that integral information infinity F square d is equal to 1 2 by integral infinity since F omega square d omega. The relation given in question 1.94 is times the Parseval Parseval times Fourier negativity with energy. It can be So by using Parseval understands that is equal to xt and yd is equal to xt minus time delay. After same energy, another expression Parseval attempts as follows. The difference in the reference to x dx is at the f of x taken the difference in the f of x dx dfx. Average power autocorrelation. Especially the average value for using xt is given by x per t is equal to limit t infinity 1 over time period is equal to period x second half minus of x over t. The instantaneous power of x is given pxt is equal to x squared. If the synchronous x-axis for the whole interval minus interval plus interval infinity, sorry, minus infinity plus infinity. The total power px is different for using xt as the power t is spread into one ohm system. Final voltage xt is applied to this resistor or current xt follows to the resistor. Dx is to the limit t infinity and t integral alpha periodic minus half periodic sigma time x squared d. One previous definition of the notum is px corresponds to the scale of the units of the signal xt, volt scale, ampere scale. These units will only be converted to volts if they are known as per units of impedance ohm. It is common to use express the power in the C, but the power in the C is given by the expression Px is equal to the 10 log Px. The total power of Px contains two components, one DC component due to non-zero average value. The signal XTP DC and then AC components. PC AC means alternative conditions means direct current. The direct current power of the signal is given by PTC to the X per D to the whole scale. It proves that AC power can be terminated by the DC perform the total power, that is PSC is equal to PX minus PDC. Time autocorrelation of signals. The average time autocorrelation is a time delay or simple autocorrelation for the real signal x is defined as x time delay is the limit time, the half time period in half, take a half time period of periodic signal minus half time period x xt plus time delay. The change of paper y is t plus time to the loss section 1.0 to be latest. X time to the limit time integral 1t by integral half time integral minus half x t minus t by t. Function 1.0 and 1.0 t for set x in time please in function of time delay, thus ix minus time delay ix time delay. From the definition of autocorrelation, power follows that Px to the x in and PDC to the x infinity. That is from this autocorrelation function it is possible to obtain information but the autocorrelation function can also be considered if we consider by taking Fourier transform. Fx time to is equal to infinity plus infinity minus the limit time integral around the one of time period integral of time period of x in the minus periodic in of time xt plus time delay e minus j omega t time delay. So the limit t infinity on the half time period of periodic in time periodic signal x integral plus infinity minus xt the plus time delay derivative time delay t. Single limit thing implies infinity on t integral t to minus t to the xt plus omega e g omega till x omega limit t omega 1 t integral of the time periodic signal xt e g omega then is equal to limit t omega x minus omega t. Is equal to limit t infinity x omega x minus omega t is equal to limit t infinity x omega square t. The power spectral density xx of a signal xt is defined as the Fourier autocorrelation function. Xt of x that is x is an f integral selecting now x in the time to the e minus j omega time to the. Examples of quantity power spectral density of the sinusoidal signal xt equals omega d my plus theta. This is sinusoidal signal. Solution. Rx t is equal to limit t is equal to infinity 1 of t infinity half of time projection s square cos omega t plus theta cos omega t plus time to the plus theta s square double s square half limit in this to implies infinity 1 of t half time periodic signal cos omega का time to the delta t plus integral of time periodic signal cos 2 omega t plus omega time to the plus 3 theta t. A square over 2 cos omega to notice that autocorrelation function this in figure 1.6 is independent of the phase theta power cancellation frequency and given by. This is figure 1.6 autocorrelation Sx omega f Ix time to the Sx omega pi a square over half impulse omega plus omega plus impulse function omega is omega naught. Quantity power means characteristics is given by px Ix square a square plus 2 and power spectral density of this sinusoidal signal. Thank you very much. Please like, comment, share, and subscribe, and don't forget to bell icon. And if you have any queries, do comment in the comment section. In the next video, I will be tell about these problems, which are all the questions which I discuss in this lecture. So, be take care, goodbye, and enjoy your time with family. Allah Hafiz and good.